Hi guys, today I want to talk about how to use Azure Blob Storage to create backups of your data. Now I want to make a distinction between a backup and an online file service. So if we're thinking about a backup, what we're talking about is a periodic snapshot or copy of your data from your device to external storage. And you take that external storage and you store it in case something happens to the original data. Say the device is stolen or it's destroyed or there's hardware failure, you can go to the backup and then restore the data once you have a new machine or a new device. And this pretty much there for insurance purposes. So you can guard against data loss with a backup. Now, a file sharing service can kind of do that, but it's oriented around collaboration. So with an online file sharing service like OneDrive or Dropbox or Nextcloud, what you have in that case is an agent that is basically there to synchronize data between the cloud and your device almost in real time. So if I'm working on a document and I save it, it's sent up to the cloud, it's copied up to the cloud, and other people can work on the same document. And when they save it, it's synchronized back down to my device and to any other device that is working on the same document. So file sharing services are oriented more around collaboration and sharing, while a backup is designed for archiving data against and guarding against loss. So both of these use cases are valid use cases, but archiving data and backing up data is typically going to be using external storage that is going to be more cost effective. So I get more storage capacity for less money than if I was using something like an online file sharing service. So it's basically designed to be there in case I need it, but not to be readily accessible at the drop of a hat like I would with an online file sharing service. Now that we looked at the difference between a backup and file sharing services, we're going to look at some of the features of blob storage that can be used for creating backups of your data. And we'll also look at some of the utilities that you can use for creating these backups from your local device to Azure. Let's look at the different tiers of storage on blob storage. There are three tiers we want to look at, and each tier has associated with it basically storage costs and access costs. So storage costs are associated with the cost of storing data, like basically the price per gigabyte of data. And the access cost is how much does it cost to use the APIs to read and write data to that given storage. So each tier will have a different class of storage and a different access cost if you want to look at it like that. So hot is probably the most commonly used one, and hot storage is going to have high storage costs, but typically going to have lower access costs. And it has higher storage costs because it uses a more premium storage. It has higher throughput and more IOPS, output operations per second. So you can read and write data more readily to a hot tier than you could some of the other tiers. And so it's going to be more conducive for applications that need to update data more frequently. Now, if you're going to be updating data less frequently, then you might want to use the cool tier. The cool tier basically uses a less premium grade of storage, so it's got lower storage cost per gigabyte, but it charges more for the actual API usage. So in this case, you end up paying more for accessing the data, but you pay less to store the data. And so this is a good balance between access costs and storage costs, but it's typically used for folks that want to have data readily available to them, but aren't going to be updating that data very often. So you might have a file that you're going to write once, and it's going to be out there in the cool tier, and you're basically just going to keep it around for a while, and then after a while, maybe you delete it, or you archive it or something like that. And that's what this tier is primarily aimed at. Then lastly, there's the archive tier. Now, the archive tier is designed for long-term storage. So this is going to be a tier that if you want to just store something for the purpose of keeping it around for retention policies or something like that, it's going to be really low cost in terms of the storage cost, but it's going to have high access costs because basically with archive, the storage is offline storage. So it's not attached to a network. So to access the data, it has to go through a rehydration process to move it from the archive tier to one of these other tiers. And there's a cost associated with that because it is offline storage. So basically you have to mount the storage and then move the data from the archive tier into one of these other accessible tiers. And therefore it's going to require some more costs associated with that. But it's designed for keeping that data in an offline capacity for the purposes of basically just retaining the data without any intent of actually changing the data. And so that's kind of what we're going to be looking at here. Now that we've talked about the different tiers, there's a tool that we can use inside of Blob Storage to optimize our costs around these different tiers, and that's with Lifecycle Management. Now, Lifecycle Management allows me to move the data between different tiers on Azure. So if I was uploading data for the first time, what I probably want to use is the hot tier. So I want to land the data on Azure using the hot tier. Now, the reason why I want to do that is because I'm going to get lower API costs for pushing data into Azure. Now, the data going into Azure is going to be free, but I still have to use the Access APIs to write that data, which does cost minimal amount of money when I'm using the hot tier, but it's going to be in this higher cost storage right here. So I upload the data using this tier, but after a period of time, what I might want to do is take it from the hot tier and move it into the cool tier, say 2 weeks or 30 days. If I was working on a project, say something like a collaboration that I'm changing a document often, I might want to keep the document hot. So it's going to be updated. And so that blob is not going to be something that's going to be flagged for moving into cool because the last modified date was something that was relatively recent. Let's say I finished the project and then 30 days later, I'm not accessing that file anymore, then it might go to cool storage. And that's where I can move that data automatically using a lifecycle management policy. And then after it's in the cool storage, I can take advantage of that cost savings around the cheaper tier of storage for cool data. But if I needed to access that data, of course, it's going to cost me a little bit more. But the intent is I'm assuming that because I haven't touched the document in 30 days, that I'm pretty much done with it. I can just store it in cool storage because it's more of an archive at this point, not something I'm actively working on. Now, if it stays in cool storage for a while, maybe 2 months or maybe 90 days, whatever it might be, then I might want to take it off of cool storage and move it into archive. And then archive is just basically putting it on ice for perpetuity. So this might be for retention policy or whatever. I'm just putting it into the archive, and that's going to be very low cost because it's basically offline storage. I'm not going to be accessing it. It's there in case I need to dredge it up again. But for most of my intents and purposes, it's pretty much done with that. And the only reason I might want to access it is in case I have a total loss, say my device is stolen or there's hardware failure and I need to restore the data from that archive. In that case, then I would just go through a rehydration process, which is going to move the data back into one of these other tiers that make it accessible. And that does cost money, but generally speaking, if the data is sitting in archive, that's not going to be very much considering the cost savings that I'm going to have for sticking it inside of this storage tier for archiving it. So the only reason I would access it in that case is if I absolutely needed to. So using lifecycle management, I can save money by basically setting all that up. Now, there's one other feature that I want to mention here, and it's really harder to illustrate with this, but it's with versioning. And that's mostly going to be relevant when I'm working with something that's going to be in the hot tier right here. Now, with versioning, basically what this allows me to do is when I make a change to a blob, what Azure Blob Storage can do is it basically creates a version of the blob. So I have V1 right here, and V1 is then going to be superseded by V2 of that, but I still have the old V1 available if I need to go back to that. So V2 becomes the current version. And then if I update it again, I get a third version and so on. So I have basically an ongoing record of all the changes that I've made to a given piece of data, and I can update that in perpetuity, and it keeps basically a copy of it going back to when it originated. And this is useful if I want to keep a copy of data for a long period of time. So if I only did weekly backups and I was changing just a few documents during the week, I might end up with a weekly version of that. So I don't have to create full weekly backups in this particular scheme. I just keep versions of my documents rather than having a full backup or incremental backup like we traditionally did in the past. I just have versions of my blobs. And then if I need to go back to a previous version, I can easily do that by looking at a given version and restore that one. And if I take a version 2 and restore it, it becomes the new version right here, rather than going back to the previous version. So that becomes just essentially V4, and I can use that as my current document as well. So with versioning, as well as using the different tiers and lifecycle management, I can create rather robust backup solutions using nothing but blob storage. Now that we've kind of talked about this in theory, let's go look at how to create the blob storage and turn some of these features on. And then we'll look at some of the utilities that you can use to actually get your data off of your device into Azure Blob Storage. And there's a couple of that I want to mention that each have their pros and cons. So to set up the storage account, we just need to start by creating a resource, and you can just type in storage account right here, and this will give us an option to create the storage account. Now we're going to just walk through the options here. So we can put it in whatever subscription you want to, and I'm going to create a new resource group. I'm going to call it BK up or something like that for backup. And then on the instance details, we got to give it a name. I'm going to call it Blaze BK up, say 1 or something like that, and then use East US. Now you can choose what performance tier you like, but for backup, standard is probably good enough for what you're going to be using. Now, if you need a more high performance tier because you're going to be putting a lot of data in there, then you might want to go with premium or something like that. But in any case, standard is going to work fine from here. Now, for the redundancy, you can use one of these other options. Locally redundant storage basically means that you have 3 copies of the data written in an Azure data center. Geo-redundant storage means that it's replicated between Azure regions. Zone-redundant means that it's within a region, but different zones within that region. Then geo-zone-redundant region storage means that it is in 2 different regions and 2 different zones in those regions. So this is the most basic one, which is probably fine for backups. So I'm going to choose that. Now, under this advanced right here, you can choose some of these other options. Now, we don't need a whole lot of this stuff right here. We probably do want to ensure that it is using a minimum version of TLS. You can use an older version if the clients that you're going to be using don't support it. But for everything I'm going to show you, TLS 1.2 is probably what you want to enable. And we don't need hierarchical namespaces or anything like that. We want to use the default to hot. We don't want to use cool. We want to default to hot because the uploads are generally going to be pretty intense, especially from the original upload, the original push of the data. Everything after that will be more of a delta, but you still have to query the API quite a bit. So we want to keep the things in the hot tier for that. And then the rest of that we can keep as is. So under networking, we can enable it from full access from this right here from all networks, but you can limit it if you want to use a private connection and so on, but I'm going to leave it open to all networks. You can also have some data protection right here with this. You can choose to use a soft delete policy. Basically what that means is it prevents you from explicitly deleting a blob. So if you delete a blob, you have within a 7-day window to restore that blob, even though it's marked for deletion. So you can do the same thing on containers and blobs. And you, of course, can do soft deletes on file shares as well, but we're not going to be working with file shares. So we are mostly concerned with these 2 down here. Now, tracking down here is what we might want to turn on. We want to enable versioning on blobs if you want to enable that versioning feature I mentioned. And this will allow me to maintain a previous version of the blob if I want to go back in time for a particular file in the case that my file gets corrupted or something like that and it gets backed up in its corrupted state. So enable versioning will give you basically backups of going back in time for how many you need for that. Now we can take the defaults on the encryption, so Microsoft managed keys and then blobs and files only, which is fine for this. And then we can skip over the tags if you're using tags and then review and create. And then this will allow us to create this particular resource. So now that I've got the storage account created, the first tool I'm going to look at is Azure Storage Explorer. Now, Azure Storage Explorer is pretty straightforward. It's basically just the graphical user interface for storage accounts that you can install locally. So it allows you to upload, download files and manage your storage accounts. So you can go to this page here, and I'll link it in the video description below, but you can just grab this for Windows, Mac OS, or for Linux. And once you install it, you can open it up and then log in. But we're going to use, you can use just a standard login and log into your Azure storage account just by way of providing credentials right here, or you can create a shared access signature for your container for your backup. So to do that, I'm just going to show you how to create a shared access container. But first I'm going to create one. I'm going to call it BKU for the container itself. And this is for the blob storage. And then on this, you have this option for shared access token. And we're just going to create one with this. So storage access tier policy, I don't have any created. So we're just going to create one here. I'm going to give it all the permissions like that. And then I'm going to give it some arbitrary date in the future, like 2 years, and then generate a SAS token and URL. Now, the one I'm going to be interested in is this blob SAS URL right here. So I'm going to grab that guy and I'm going to make a note of it in a text editor off screen right here, but we're going to need it in a moment. But in Storage Explorer, you have the ability to connect with this guy. So I'm going to click on the connection icon and I'm going to say storage account as service right here, or you can do a blob container. This is a blob container, and I'm going to use shared access signature URL. Then I'm going to paste it in, and it's called BKU1, and connect. And then that will provide me a connection to BKU1, which currently doesn't have anything in it. Now, to upload to this, it's pretty straightforward. Now, if you were going to do manual backups, this would be probably the tool you might want to use. And you can upload files and folders with this. I'm going to upload a folder, and I'm going to choose the folder right here. And basically just go to /BKup right here. It's just a folder, and select this folder, and then the destination would be the root of the container. And then you can click upload. And this is going to upload a couple of files that I have in this folder. I think there's about 50 or so files. And so once that's uploaded, everything will be completely in that particular blob storage account. So this tool uploaded about 31 files into the blob storage right here. So if I go into this folder right here, you can see those have been uploaded. Now, this is just showing you the files. Now, this particular tool is good for maybe an initial upload into blob storage, but it doesn't really have a lot of ability to do any kind of deltas or syncing. And that's where some of the other tools might be useful. So this is a great tool for kind of getting the data up there. But there's a feature of this that I like. It's called copy the AZCopy command, which will copy the command that this app used to move the data up into Azure Blob Storage. And that will allow us to create some automation around this particular command. Besides the initial upload and getting the AZCopy command, this is just a good way to browse the files to restore them to whatever state that you need to restore them to. And so you can do like manage versions and snapshots right here. If you want to restore a previous version of a given blob, or manage a snapshot, which is a feature I didn't mention, you can go back and look at a given file and see its version history using this utility and then restore it. You can do a lot of things like that using Azure Storage Explorer, which is a great tool for doing that kind of operations. But for automation, this is probably not the tool you would want to use. You'd probably want to use AZCopy or another tool I'm going to mention called RClone. But in any case, since we already grabbed this, let's go ahead and look at AZCopy. So here's the page for AZCopy that you can get for download. Now, the download for this is for Mac, Linux, and Windows. And you can get the 64-bit version for Windows, which I'm running here. Any of these would work. It's just the binaries, so you would need to extract the binaries and put them somewhere on your drive. So if I was working with this, I might just go into here, take AZCopy, and I like to put these into like my System32 folder on Windows, because that's part of the path variable for the environment variables in Windows. So I can just type in AZCopy and it's available to me, and it's kind of a system type executable, so it does fit to put it here. In any case, that is now available, and I can use this to run my backups using a command line utility. Now that I've pasted that file into the System32 folder, I'm going to come back over here and copy the command that I use to basically upload the files right here. So on this line right here. And I'm going to put this into a text editor so we can see what's going on here. Now, this is just PowerShell. So you could run these in PowerShell, create a PowerShell script from this. Now, this is just setting the credential type, and then this is setting concurrency. On my connection, I want to set that to 32, because if you set it to a large number, it will typically choke out the connection and cause problems with the upload. And that's not really an issue with my machine as much as it is with the bandwidth allocation that I have from my ISP, which isn't great for uploads. So your results may vary depending on what value you set this to. You can set it to auto and it may work just fine, but it doesn't work on my connection. So basically what this is going to do is copy the files up to Azure using AZCopy. Now, since I've already done that, I actually want to change this command a little bit. I'm going to change it to a feature called sync, and that's just basically going to look for changes in this folder right here, and then upload the changes to blob storage. And there's a couple of these parameters down here that I can remove. I don't need a couple of these things right here. Let's see. I don't need from overwrite prompts right here. I don't need that. I don't need this one. That one, follow symlinks. I don't need that. That would be important if I was on Windows. I'm sorry, on Linux or Mac, but on Windows, you don't have symlinks. Put MD5 I do want, because it puts the hash into the metadata on the blob. And disable auto decode. I'm going to turn that off, and I can leave those two flags, recursive and log level info, as is. And so that will give me the ability to sync the data rather than just do a full copy of the data. And so if I actually run these commands, let me get a PowerShell instance here, and we can run these commands right here explicitly, or I can create a shell script for it. And then let's go ahead and just paste these in. I think it's got a terminal right here. And you don't have to actually do some of these commands right here for concurrency, as I mentioned. But it does help expedite things. And if I run this thing as is, like this, just this AZCopy command like that, I do need to modify this command a little bit so that it's not, doesn't have that // there. And that's going to actually run this. And it's going to look for some differences. And it's probably going to try to upload some files. It's basically just checking some deltas here. And then when it's done checking everything, it's going to say done, and everything should be good to go. So that's what I can do to run this particular file. Now, if I wanted to create some automation around this, this would be what I would want to use for that automation. So the automation is basically creating a PowerShell script that's going to run on a timer, cron job, or what have you. Now that looks different depending on what operating system you're using. But if I wanted to save this off, I could do that. I could put this into my // let's put this back into my backup folder on my root here that I was using for this. And let's just create a PowerShell script, call it bkup.ps1. And that's going to create the PowerShell script. And if I create a scheduled task, task scheduler here, I can create a task using task scheduler right here. Probably just use basic tasks, since this is just a particular file that I want to run. It's just a command, and let's call it backup. And next is the trigger. You can tell it how often you want to run. I can run it daily, weekly, monthly. Daily is probably good. Weekly is probably fine too, but I'm going to do it daily. And you can set the schedule. So if I want to do it at, say, 12 in the morning, and if my machine's on, you could do that. Start at, recur every 1 day. The action, start a program, send an email, display a message. I'm going to start a program, and basically I'm just going to point it to that script. And that script is on my C drive right here. There's pictures of my daughter. That's what I'm using for this. And everything's embedded in there, so I don't need to have any files or start parameters, and next and finish. And now that job is scheduled to run. So that will give me my backup to run on this particular machine whenever it needs to run, which is basically every day at midnight. So all that is ready to go. Now you could use cron tabs on Mac OS and Linux to do the same thing if you're writing a shell script to do that. In any case, I just did it for PowerShell here. So now that we've looked at both the GUI using Azure Storage Explorer, and we looked at the command line for doing a sync, let's look at one other tool that you might not have considered. It's a non-Microsoft tool, but it could work similar to what you would get from something like AZCopy, but it's a little bit different, and it's a little bit different approach because it handles a lot more different permutations for different kinds of backups, like you might want to think about whenever you're looking at using another tool. So it's just another option if you want to consider that. So the last tool I'm going to show you how to use is RClone. Now this is a tool that's not from Microsoft. It's a third-party tool that allows you to sync between all kinds of different online file stores. So this would work for not only blob storage, but it could work with Amazon S3, it could work with OneDrive, it could work with any number of other cloud providers. It's just basically a general purpose utility for moving data around. Now, this one is very similar to what we did when we were downloading the AZCopy. When you come here to downloads, of course, you can download the app that's in a precompiled state, or you can download the code and build it yourself, but we have it for Windows right here. I'm going to download it for 64-bit Windows, and it's just the executable. So similar to what I did with the AZCopy utility, I just put it in the System32 folder on Windows, and I've already done this, so I'm going to replace it, but it's going to basically put it in a place that I have accessible from anywhere on my drive. So now that the actual app is installed, it's pretty straightforward to set up. So I'm going to walk you through how to do that, and then we'll set up a cron for this one as well. So now that I've copied RClone, I've launched PowerShell here. You can use Command CMD if you want to, but either case, basically what we want to do here is configure this. So to configure RClone, you just type in RClone config. So it's not too intimidating to use the command line to configure this guy. It's pretty straightforward. So I need to create a new remote. And so I'm going to hit in, and I'm going to call it Blob Storage Backup or something like that. And I'll need that later whenever I can configure the CLI to actually run the job. And it's going to give me a list of all of the different cloud options for storage online that I have. And of course, you see that I have SSH, SFTP, I have that SMB for like cloud storage on something like Azure File Storage. I could use OneDrive, of course, blob storage. So I'm going to use 30 for that. And it has S3 buckets, of course, Google Drive and FTP, other options like Dropbox. So it supports a lot of different options. So I'm going to select Azure Blob Storage, which is 30. And now it's going to ask me for the parts of the configuration it needs to authenticate RClone with Azure Blob Storage. So the storage account I can get from the Azure portal, and that's just going to be right here. So I'm going to grab this, and it's just BK Blaze Backup 1. And this one is asking me, do I want to use any credentials from the environment? I'm going to say no to that, or leave it false. This is asking me if I want to use a shared access key, which I'm not going to be used. I'm going to use a SASH URL, so I'm going to leave that blank. Now, this is the SASH URL that I grabbed earlier, but you can configure these very easily. Just go into your container, click shared access token, give it some arbitrary long date in the past, and then make sure that you have all the permissions available, and then click generate SASH URL, and you can copy that and just paste it right here and go with that. And you can leave this blank because I'm not using any kind of service principals or IDs. If you want to do that, that's perfectly fine. And so I'm going to leave those blank, client secret, client's path, and then I'm going to hit no for that. And then I don't want to use the advanced config. I'm just going to take the defaults there and keep this remote. Yes, I'm going to hit enter. And now I have Blob Storage Backup is the name of this remote. So I can quit config now, and I can run my job now. Now to do that, I just need to provide RClone with a command. So basically it is RClone, and then you tell it the command that you want to use, which I'm going to be using sync, which is basically going to synchronize files between my local store and my backup. And then I'm going to say source and then destination. So pretty straightforward. So I'm going to go RClone, and I'm going to say sync, and then I'm going to say what is my local, which is going to be /BK up, like we saw a minute ago. Let's put that in quotes like that, single quotes, in fact. And then my destination is the name of the remote, then the name of the container, which is called BKU, and then the path on the container, which is called BK up, like that. So that's basically saying, synchronize everything that's in this folder with everything on blob storage at this remote in this container at this folder in the container. And if I do that, it should run the job. Currently, there's nothing to sync, and that's why that ran fast because everything is currently in sync. It's just basically looking at what's there and what's local and then comparing the two. So if I wanted to sync something, make a change and use that. So let's make a material change to one of these so we can see one of these pictures. So let me open up this one right here, and let's just edit it in paint.net, and let's just crop it a little bit right here. And I already have these pictures somewhere else, so I'm not actually butchering it. So let's just crop this, save this file off, and then now I have a change inside of this folder. And then I should be able to pull up my folder, my RClone again, and run this again. And that will make a material change to the folder. So everything is now going to be, synced back and forth, of course. If you want to do this interactively, you can do -I, and that will run it interactively, and it'll tell you if something is changed. If I did add -I, it's not going to show me anything because I don't have anything to sync. So all the checks ran and it was fine. So I like RClone better than AZCopy for backups, and that's why I'm showing you this utility. Once everything is synced, RClone seems to do a better job at actually detecting material changes in files that you can then get a much quicker sync between your local and your remote using RClone. So with that in mind, I'm just going to take this command right here, and that's what I'm going to use inside of my cron. So if I want to create a backup for this one, it's pretty straightforward. I can create a basic task right here, and let's call it backup 2 like that, and do it daily. And I can run it, start every day. This is 12 at in the midnight or something like that. I don't know. And you can run it at noon if you wanted to, and AM, and run every day. And then next, and then start a program. I can then run RClone like that, and then I can have the additional arguments and features like that for optional, and then just next, and then finish. It's going to start program RClone sync, and then that's going to pass in these parameters right here, and that's what it's going to look like. And then click finish, and now I have that backup ready to run. So this operation will run every day at midnight. So assuming my computer is on. Now, if you wanted to run it, say at noon, whenever you're using your computer or something like that, it'll run in the background. Of course, it won't run it in the foreground because it is a scheduled task. And this is also going to run as the user that I'm logged in as. So it'll still have access to the configuration files of RClone. So that's now scheduled to run, and it will work just fine. So we looked at 3 different utilities. So we looked at Azure Storage Explorer. This is great for interacting with individual files, maybe doing an initial upload. We looked at AZCopy, and then of course RClone. Any one of these utilities will work for this. I have one more thing I want to show you though before we wrap up this video, and that's how to set up the lifecycle management so that we can move the data between the different tiers. So to set up the lifecycle management, we need to go down here to data management and select lifecycle management right here. And this is where I can add rules. So if I click add rules, I'm going to go add a couple of rules to this. One rule is going to move data that hasn't been touched into cool storage. So basically, if it hasn't been touched for 30 days, I'm moving to the cool tier. Then after another 150 days, I'm going to move it into archive. And that's only going to apply to my base blobs, which is basically anything that's not a snapshot or anything that's not a version. Now, after 30 days, I want to delete my versions and delete my snapshots. So I'm only going to be moving the base blobs into my storage accounts that are going to be in the archive and cool tier. So to do that, I'm just going to come down here to block blobs and select base blobs, and I'm going to say move to cool. And this is where I'm going to say after 30 days, if it has not been modified, I'm going to move to cool storage, and then click add that. Then I'm going to add another rule here, and this is the one that's going to move into archive. So move to archive. And again, apply this one to storage accounts, and then apply it to block blobs and my base blobs. And then it's going to, after 180 days, if it hasn't been touched, then it's going to move it to archive. So basically, if it's in hot or cool, it should be in cool by this point, it's going to move it into archive. So I'm going to skip blobs that have been rehydrated after 7 days. That's probably fine. And then click add that rule. Now I'm going to add another rule that's going to delete snapshots and versions. And this is going to apply to block blobs as well, but I'm not going to apply it to my base blobs. I'm going to apply it to snapshots and versions. So under snapshots, if it's more than 30 days old, delete the blob snapshot. And then for version, same thing. If it's more than 30 days old, then delete the version, and then click add that rule. So now I have 3 rules. One after 30 days, move it to cool. One after another 180 days, move to archive. And then after 30 days, delete snapshots and versions. So this will keep my storage account pretty clean, and it will also move data into some of these cheaper tiers of storage that are for infrequently accessed data like cool and archive. So this will give me a fairly robust ability to upload data, change it for a little while, then after a while, just move it into archive and cool storage for that more long-term storage. And so this will allow me to have my backups running, and then I'll be able to keep those backups fresh without having to do things like incrementals and all these other kinds of schemes that you can do with more traditional solutions. Well, all in all, that is how you set up the policies. So I hope this video has been helpful for you for understanding not only how blob storage works for doing backups, but also some ways that you can do that using the utilities that we covered. We covered the Data Explorer, and we also looked at AZCopy, and then also RClone. Then we also looked at some of the features in blob storage that allow you to groom the data using Lifecycle Management, and also looked at versioning briefly. So all of these things working together will allow you to create a rather robust backup solution and have a lot of flexibility for how your data is managed on the cloud, and then how you can get your data into the cloud. So this will give you a lot of ways that you can configure and think about the ways that you're going to be using Azure for backup strategies.
If you like this content, please consider subscribing to the channel by clicking on the subscribe button. You can also like this content by clicking on the thumbs up, or share this content with your friends, and also comment in the comment section down below. You can also find me online at www.blaze.net or on Twitter at @TheOneMule. And as always, thanks for watching.